In this video, we will be solving 20 factorization problems. After each problem is presented, we will provide a step-by-step solution on how to factorize it. Make sure to comment below with how many problems you got correct. Let's get started. Pause the video now and solve the problem x² plus 5x plus 6 with the possible solutions. A, x plus 4 times x plus 5, b, x plus 2 times x plus 3, c, x plus 2 times x plus 4, d, x plus 1 times x plus 6. Let's begin with the polynomial we are given, x squared plus 5x plus 6. Given that we want to factorize this into a more manageable form, we have to remind ourselves that a quadratic function typically takes the form of ax squared plus bx plus c, where a, b, and c are coefficients. Coefficients are just fancy terms for the numbers in front of our variables x and x squared in the equation. In our case, the coefficient a is 1, as the x squared does not have any number in front of it, which means a is 1 by default. The coefficient b is 5 from 5x and c is 6. Now, we must break our quadratic polynomial into two simpler binomial expressions. To do this, we must find two numbers that both add up to our coefficient b, which is 5, and multiply together to give our coefficient c, which is 6. Let's start with the numbers that multiply to give 6. We have options such 1 and 6 or 2 and 3. Testing these pairs, we see that only 2 and 3 when added together give us our desired sum of 5. So our two binomial expressions that we will use to factorize the quadratic polynomial are x plus 2 and x plus 3. This is because adding the 2 and 3 gives us the 5 in the term 5x, our middle term, and multiplying 2 and 3 gives us the 6, our constant term. Thus, the correct solution is x plus 2 times x plus 3. In this video, we will be looking at the problem 4x squared minus 1 and its possible solutions. Pause the video here and try to solve it for yourself using the following options. A, 2x plus 1, 2, b, 4x minus 1 times plus 1, c, 4x squared plus 1, d, 2x minus 1 times 2x plus 1. We begin with the quadratic equation 4 times x squared minus 1. Let's start by factoring. Factoring is the process of breaking down an equation into simpler parts. It's especially useful in quadratic equations like this one because it could potentially simplify the equation or help us find the roots or solutions of the equation. We notice that this equation is of the form a squared minus b squared, which is a difference of squares. A difference of squares can always be factored into the form a plus b times a minus b. In our case, a would be 2 times x, because if we square 2 times x, we get 4 times x squared. Similarly, b would be 1, because if we square 1, we simply get 1 again. So using the factoring rule for the difference of squares, our equation 4 times x squared minus 1 can be minus written as 2 times x plus 1 times 2 times x minus 1. Thus, the correct answer is D. Please pause the video and try to solve the problem of factoring the quadratic equation x squared minus 9x plus 20 using the possible solutions provided. Ax minus 4 times x minus 5, bx minus 3 times x minus 7, cx minus 2 times x minus 10, dx minus 5 times x minus 6. Good luck. We begin by analyzing the given expression, which is x squared minus 9x plus 20. We want to factorize this expression, essentially breaking it down into component expressions whose product will give us back the original expression. For expressions in the form of x squared plus bx plus c, such as the one we have here, we need to find two numbers that multiply to give c, which is 20 in this case, and add up to give b, which is minus 9 here. Let's consider 4 and 5. Multiplying 4 by 5, we get 20, which is the constant term in our given expression. And if we add minus 4 and minus 5, we get minus 9, which is the coefficient of the x term in our expression, after considering the sign. Now we're going to write the given expression as x squared minus 4x minus 5x plus 20. Notice that this is the same as the original expression, because minus 4x minus 5x is indeed minus 9x. But writing it this way allows us to do something important. We can line up terms that have common factors, which we can then factor out. Let us break the equation into two parts and factor it like so. X times x minus 4 minus 5 times x minus 4. Now we have two terms, and it looks like x minus 4 could be a common factor. Indeed, factoring out x minus 4, we get x minus 4 times x minus 5. Hence, the original expression x squared minus 9x plus 20 factorizes to x minus 4 times x minus 5. Thus, the correct answer is x minus 4 times x minus 5. Pause the video and solve the problem presented. 2x squared minus 8x plus 6 and its possible solutions. A. 2x minus 2 times x minus 3. B. 2x minus 1 times x minus 3. C. 2x plus 1 times x plus 3. D. 2x minus 1 times x minus 2. Let's start with the quadratic equation, 2x squared minus 8x plus 6. We want to find the factors of this equation. The standard form of a quadratic equation is ax squared plus bx plus c. There are three parts: the coefficient of x squared, that is a, the coefficient of x, that is b, and the constant term, that is c. In our equation, the coefficient of x squared, that is a, is 2. The coefficient of x, that is b, is minus 8, and the constant term, that is c, is 6. The next step is factoring. Factoring is a way to break down the polynomial into simpler terms that, when multiplied together, give the original polynomial. The common factor in each term of our equation is 2. By factoring out the common factor, we alter the equation to become what is called the factored form, which is 2 times the expression x squared minus 4x plus 3. Our next goal is to factor the quadratic expression x squared minus 4x plus 3 further. We are looking for two numbers that multiply to 3 and add to minus 4. After thinking for a bit, we can see that two numbers satisfying these conditions are minus 1 and minus 3. So we can rewrite our expression to be x squared minus 4x plus 3 equals x minus 1 times x minus 3. So putting it all together, the factored form of our original quadratic equation, 2x squared minus 8x plus 6, becomes 2 times x minus 1 times x minus 3. Thus, the correct answer is 2 times x minus 1 times x minus 3. In this problem, we are given the quadratic expression 3x squared plus 12x plus 12 and four possible solutions. A. 3 of x minus 2 times x minus 2. B. xx plus 4 plus 3. C. 3x plus 2 times x plus 2. D. 3x of x plus 4 plus 3. Pause the video and try to solve it for yourselves before we reveal the correct solution. Firstly, we look at our given problem, which is 3x squared plus 12x plus 12. We want to factor this quadratic expression to simplify it. Now note that the factor of the quadratic term, which is 3, can also divide the other two coefficients, 12 and 12. Hence, we could factor out 3 from the whole equation. When we divide each term by 3, we get x squared plus 4x plus 4. So our new expression is 3 times x squared plus 4x plus 4. Next, we need to factor the quadratic expression x squared plus 4x plus 4. This next step involves solving the quadratic equation. To factor a quadratic equation, we need two numbers, which add up to the coefficient of the linear term, which is 4 in our case, and also the product of these two numbers should be equal to the constant term, which is also 4 in this problem. Can you think of these two numbers? Yes, the numbers are 2 and 2. They add up to 4 and their product is also 4. So we rewrite the quadratic equation as x plus 2 times x plus 2. Finally, we can't forget about the factor of 3 we factored out earlier. Multiply it back to the equation. Hence, our simplified form of the given quadratic expression is 3 times x plus 2 times x plus 2. Thus, the correct answer is 3 times x plus 2 times x plus 2. In this problem, we are given the equation x squared plus 4x plus 4, and we need to determine its possible solutions among the options A, x plus 2, 2, B, x squared plus 4x plus 2, C, x plus 2x plus 2, and D, x squared plus 2x plus 4. Pause the video and try to solve the problem for yourself before we reveal the correct answer. We begin with the equation x squared plus 4 times x plus 4. This is a quadratic equation in the form of a squared plus 2ab plus b squared. To simplify and factorize this equation, we look for two numbers that multiply to 4 and add up to 4. The number 2 fits these criteria as 2 times 2 is 4 and 2 plus 2 is 4. We rewrite the quadratic equation, breaking down the term 4x into 2x plus another 2x. This gives us x squared plus 2x plus 2x plus 4. Next, we group these terms. Here we group the terms x squared plus 2x and 2x plus 4. We are now dealing with two expressions, x squared plus 2x and 2x plus 4. As we factorize these expressions, the aim is to remove the common factor in each group. Let's start with the first group, x squared plus 2x. We can take out the common factor x, which gives us x times the expression x plus 2. Similarly, for second group, 2x plus 4, we can remove the common factor 2 to obtain 2 times the expression x plus 2. So we now have x times the expression x plus 2 for the first group, and 2 times the expression x plus 2 for the second group. Noticing that the expressions x plus 2 are common in both groups, we can take this as a common factor. So taking x plus 2 as a common factor, we factor out the equation to get the form expression times expression. The two expressions are x plus 2 and x plus 2. Thus, the quadratic equation x squared plus 4x plus 4 simplifies to the square of the expression x plus 2. Thus, the correct answer is A. In this video, we will be exploring the problem of x squared minus 16 and its possible solutions. Take a moment to pause the video and try to solve it for yourself using the following options. A, x plus 4 times x plus 4. B, x minus 4 times x plus 4. C, x plus 16 times x minus 16. D, x minus 4 times x minus 4. We start with the equation x squared minus 16. This appears to represent a difference of two squares, namely x squared and 16. A difference of squares can always be factored into the product of two binomials, in the form first term minus second term times first term plus second term. We can confirm this is the case by examining our equation more closely. The first term, x squared, is clearly a perfect square, since it is the square of x. The second term, 16, is also a perfect square, as it is the square of 4. So this matches the pattern exactly. We simply take the square root of each of the two terms in order to identify what the binomials will be. The square root of x squared is x, and the square root of 16 is 4. We insert these values into our factored form, yielding the two binomials. The formula takes the form first term, in this case x, minus second term, in this case 4, times first term, which is x, plus second term, which is 4. Therefore, as the solution to the original equation x squared minus 16, we get x minus 4 times x plus 4 as our result. Thus, the correct answer is option B. In this problem, we are given the quadratic equation 6x squared plus 13x plus 6 and 4 possible factorizations. A, 2x plus 2 times 3x plus 3. B, 6x plus 2 times x plus 3. C, 2x plus 3 times 3x plus 2. D, 3x plus 1 times 2x plus 6. Pause the video here and try to solve the problem for yourself before watching the solution. We start with the quadratic expression 6 times x squared plus 13 times x plus 6. If you remember the formula of the expression a times x squared plus b times x plus c, we can see that a equals 6, b equals 13, and c equals 6 in this case. To factorize it into two binomials, we need to find two numbers such that they add up to b and their product equals a times c. In our case, these numbers are 3 and 4, because 3 times 4 equals 12, which is the product of a and c, and 3 plus 4 equals 7, which is half of b. Split 13x into two terms using these numbers, resulting in 6 times x squared plus 4 times x plus 3 times x plus 6. Now group the terms to make factorization easier. This gives us two groups, namely 6 times x squared plus 4 times x and 3 times x plus 6. Now take out common factors from each group. The first group has 2x as a common factor, and we are left with 3x plus 2. In the second group, the common factor is 3, leaving us also with 3x plus 2. Finally, factor out the common binomial term, 3x plus 2, from the two groups. The resulting expression is then 2x plus 3 times 3x plus 2. Thus, the correct answer is 2x plus 3 times 3x plus 2. In this video, we will be exploring the problem of x squared minus 25, and looking at its possible solutions. Pause the video here and try to solve the problem for yourself. The options are A, x minus 5 squared, B, x plus 5 squared, C, x minus 5 times x plus 5, and D, 2x minus 25. Good luck! We begin by examining the given equation, which is the square of x minus 20 minus 5. Looking at the structure of the expression, it fits the form of a difference of squares. A difference of squares is an algebraic expression that can be factored and is characterized as a binomial in which both terms are perfect squares and are connected by a minus sign. To factor the difference of squares, we first identify the square roots of each term. The square root of x squared is x, and the square root of 20 minus 5 is 5. With the square roots identified, we now create two separate binomials, one for the positive and one for the negative version of the square root of the second term, which is 5 in this case. The structure of these binomials would follow the pattern of x plus or minus the square root of the constant term. For the given expression, the binomials would be x minus 5 and x plus 5. We therefore rewrite the original algebraic expression as the product of these two binomials. This gives us the factored form of our original expression x squared minus 20 minus 5 as x minus 5 times x plus 5. Thus, the correct answer is x minus 5 times x plus 5. In this video, we will be looking at the polynomial x squared plus 10x plus 25 and its possible solutions. The options are A, x squared plus 10x minus 25, B, x minus 5 2, C, x squared plus 5x plus 25, and D, x plus 5 third squared 2. Pause the video here and try to solve it for yourself. We start with the quadratic equation, x squared plus 10x plus 25. Our goal here is to convert this equation into a form that would allow us to represent it as the square of a binomial. We first observe the structure of the equation. It is in the form of a square plus 2 times a constant times x plus the square of the same constant. This form resembles that of the standard form for a perfect square, which is x squared plus 2 times some constant x plus the square of the same constant. The given quadratic equation, x squared plus 10x plus 25, therefore indicates that the constant we are looking for must be such that 2 times its square gives us 10 and its square gives us 25. On closer inspection, we determine that the constant is 5. This is because 2 times 5 equals 10 and 5 squared equals 25. Thus, we can transform the quadratic equation into the square of a binomial in the following way. We rewrite x squared plus 10x plus 25 as x plus 5, all squared. By doing so, we have now represented the equation in its simplest form. Thus, the correct answer is D. Please pause the video and try to solve the problem of factoring the quadratic equation, 2x squared plus 7x plus 3, with the given possible solutions. Choose the correct answer between A, 2x plus 2 times x plus 1, B, 2x plus 3 times x plus 1, C, x plus 2 times 2x plus 3, D, 2x plus 1 times x plus 3. In the given problem, we have a quadratic expression, 2x squared plus 7x plus 3. The objective here is to express this quadratic expression as a product of two binomial expressions. This procedure is called factoring the expression. Let's go step by step in the process. The general form of a quadratic expression is ax squared plus bx plus c, where a, b, and c are the coefficients. In our case, a equals 2, b equals 7, and c equals 3. The initial step in this type of factoring problem is to multiply the coefficient a, which in our case is 2, and the constant term c, which is 3 here. 2 times 3 equals 6. The next step is to find two numbers that multiply to give the product that we have just found, which is 6, and also add up to the coefficient b, which is 7. The numbers that satisfy these conditions are 1 and 6, because 1 times 6 equals 6, and 1 plus 6 equals 7. These numbers will guide the splitting of the middle term, 7x, in the initial quadratic expression. The expression will be rewritten as 2x squared plus 1x plus 6x plus 3. The next step is to look for common factors in the first two terms and in the last two terms. For the terms 2x squared and 1x, the common factor is x. Let's factor that out to get x times 2x plus 1. Similarly, in the terms 6x and 3, the common factor is 3. Factoring it out, we get 3 times 2x plus 1. Notice that the expressions in both brackets are the same, 2x plus 1. This allows us to factor the expression even further. The final factored form of the expression is thus the repeated binomial, which is 2x plus 1 times the sum of the factored minus out terms, which are x and 3. So the factored form of the given quadratic expression, 2x squared plus 7x plus 3, is 2x plus 1 times x plus 3. Thus, the correct answer is D. In this video, we will be exploring the problem involving the expression 9x squared minus 1 and its possible solutions. The solutions are as follows. A, 3x plus 1 squared 2. B, 9x squared plus 1. C, 3x minus 1 times 3x plus 1. D, 3x minus 1 is 2. Pause the video here and try to solve the problem for yourself before we reveal the correct answer. To solve the equation 9x squared minus 1, look for a special factor form called a difference of two squares. A difference of two squares is an algebraic expression of the form a squared minus b squared, and it can be factored into the product of a minus b times a plus b. In the case of 9x squared minus 1, notice that this is a difference of two squares. That is, 9x squared is 3x all squared, and 1 is 1 squared. So we can rewrite the expression as a difference of two squares, so it becomes 3x squared minus 1 squared. Now let's use the formula for a difference of two squares and rewrite the equation. So it becomes the product of 3x minus 1 and 3x plus 1. Thus, the correct answer is C, 3x minus 1 times 3x plus 1. In this video, we have the expression x squared minus 6x plus 9, and we are asked to find its possible solutions. The options given are A, x plus 3, 3x through 2, C, x minus 9x plus 6, D, x squared minus 3x plus 9. Pause the video here and try to solve it for yourself. Consider the quadratic expression x squared minus 6x plus 9. The objective here is to express this quadratic expression as the square of a binomial. First, let's focus on the coefficients of the quadratic and linear terms. Notice that the middle term minus 6x has a coefficient of minus 6, and its absolute value, 6, is twice the number 3. This potentially suggests that the expression might be a perfect square trinomial, where the square root of the first term, x, and the square root of the last term, 3, form the binomial. Next, we check the last term, which is positive 9. The square of negative 3 is also positive 9. This further supports our hypothesis that the given quadratic expression is a perfect square trinomial. The current quadratic expression can be expressed as the square of the binomial x minus 3. Here's why. If we square the binomial x minus 3, we apply the formula for squaring a binomial, which is a squared minus 2ab plus b squared, where a is x and b is 3. Squaring x gives us x squared. Multiplying x by 3 gives us 3x, and when we double that, as the formula requires, we get minus 6x. Squaring 3 gives us the 9 at the end. Putting these together, we get x squared minus 6x plus 9. This matches the given quadratic expression, so we can conclude that this expression is indeed the same as the square of the binomial x minus 3. Thus, the correct answer is x minus 3 the whole square. In this problem, we are given the quadratic expression 4x squared minus 4x plus 1, and we need to determine which of the following expressions is a possible solution. A, 4x squared plus 4x plus 1, B, 2x minus 1 squared 2, C, 4x squared minus 2x plus 1, D, 4x squared minus 4x minus 1. Pause the video here and try to solve the problem for yourself. We start with the quadratic equation, 4x squared minus 4x plus 1. This equation matches the form of a perfect square trinomial, which is squared minus 2ab plus b squared, with a being 2x and b being 1. Let's break it down using these values. First, we have a squared, which is we take a as 2x and square it. It gets us 4x squared. Then we have minus 2ab, which is we multiply 2 by a as 2x and b as 1, and it gets us minus 4x. Lastly, we have b squared. If we take b as 1 and square it, it gets us 1. No modifications needed for the given equation because all parts of our equation indeed match the form of a perfect square trinomial. Now, if we rewrite this perfect square trinomial in the format a minus b all squared, a being 2x and b being 1, we get our final solution to be 2x minus 1 all squared. Thus, the correct answer is 2x minus 1 all squared. Pause the video and try to solve the problem presented on the screen. The expression is 3x squared minus 18x plus 27. You have four possible solutions to choose from. A, 3x minus 3 2, B, 3x squared minus 9x plus 9, C, x squared minus 6x plus 9, or D, 3x squared minus 6x plus 9. Take your time to analyze the options and see which one best fits the given expression. Good luck. We begin with the quadratic expression 3 times x squared minus 18 times x plus 27. Our aim is to rewrite this expression as a complete square. Recall that a quadratic equation can be expressed in the form a times the quantity x minus h, all squared plus k. Here, h is the x minus coordinate of the vertex, k is the y minus coordinate, and a is a constant. Let's start by factoring out 3 from the expression. This gives us 3 times the quantity of x squared minus 6 times x plus 9. Next, we want this expression in the form of a complete square. Using the pattern a squared minus 2 times a times b plus b squared equals the quantity a minus b, all squared. We can observe that the first term is x squared, which we can consider as a squared in our pattern. The second term is minus 6 times x, which would become minus 2 times a times b. Equating these two expressions, we have 2 times a times b equals to 6 times x, hence a equals to x, and b equals to 3. Lastly, 9 in our expression would stand as b squared. Therefore, by comparing our expression to the complete square formula, we get that our expression can be rewritten as x minus 3, all squared. Finally, don't forget to multiply back in the 3 we factored out earlier, giving us the expression 3 times the quantity of x minus 3, all squared. Thus, the correct answer is A. In this problem, we are given the quadratic equation 8x squared minus 2x minus 3 and 4 possible solutions. A, 4x minus 3 times 2x plus 1. B, 4x plus 1 times 2x minus 3. C, 2x minus 3 times 4x plus 1. D, 8x minus 3 times x plus 1. Pause the video here and try to solve the problem for yourself before we reveal the correct solution. We start with the quadratic equation 8x squared minus 2x minus 3. Now the aim is to rewrite this in the form of two binomial expressions multiplied together, each with two terms following the pattern a times x plus or minus b. We can start by factoring out a common factor if there is any. No such common factor exists in this case. We then proceed to break down the middle term, in this case 2x, into two parts whose individual products sum up to the product of the coefficient of x squared and the constant term. In this scenario, the coefficient of x squared is 8, and the constant term is minus 3. Therefore, the target product is 8 multiplied by minus 3, which equals minus 24. After some trial and error, we can find out that the two numbers satisfying this requirement are minus 6 and 4. This is so because minus 6 times 4 equals minus 24, and minus 6 plus 4 equals minus 2, which is the coefficient of the middle term. Hence, we rewrite minus 2x as minus 6x plus 4x, rewriting our original quadratic expression as 8x squared minus 6x plus 4x minus 3. Next, we group together the first two terms and the last two terms separately, then factorize each group. We obtain 2x times 4x minus 3 and 1 times 4x minus 3. By observing carefully, you can see that 4x minus 3 is a common binomial factor in both groupings. Finally, we rewrite the expression to indicate this common factor. When you factor out 4x minus 3 from the two groupings, we get 4x minus 3 times 2x plus 1. Thus, the correct answer is 4x minus 3 times 2x plus 1. In this problem, we are presented with the quadratic equation x squared minus 4x minus 21 and 4 possible solutions. A, x plus 7 times x plus 3. B, x minus 3 times x plus 7, C, x minus 7 times x minus 3, D, x minus 7 times x plus 3. Pause the video here and try to solve the equation for yourself. We are going to solve the quadratic equation x squared minus 4x minus 21 equals 0. Firstly, let me remind you of the generic form. A quadratic equation is generally written in the form ax squared plus bx plus c equals 0. Comparing this with our given equation x squared minus 4x minus 21, we can see that a is 1 since there are no other numbers in front of the x squared, b is minus 4, and c is minus 21. To solve a quadratic equation, one common technique is factoring. The first step in factoring is to express the equation in terms of its constituent binomial products. We will do this by splitting the middle term, the one involving x, into two terms such that the sum of their coefficients is minus 4 and their product is a times c, which in our case is 1 times minus 21. This implies that we are looking for two numbers that when added together give us minus 4 and when multiplied together give us minus 21. These two numbers are minus 7 and 3. To see why this is the case, notice that minus 7 added to 3 is indeed minus 4, and minus 7 multiplied by 3 is indeed minus 21. We can now rewrite the middle term, minus 4x, as minus 7x plus 3x. Replacing this in our original equation, we get x squared minus 7x plus minus 21 equals 0. Now, we group the terms 2 by 2 and factor out the common term in each group. For the first two terms, we have x as a common term, and for the last two terms, we have 3 as a common term. Doing this gives us x times x minus 7 plus 3 times x minus 7 equals 0. After that, you can see that we have factor x minus 7 is repeated. We take it as a common factor, yielding x minus 7 times x plus 3 equals 0, which is indeed the correct answer in factored form. Thus, the correct answer is D. Please pause the video and solve the problem presented on the screen. X squared plus 11x plus 30 and its possible solutions. A. X plus 2 times x plus 15. B. X plus 3 times x plus 10. C. X plus 4 times x plus 7. D. X plus 5 times x plus 6. Let's start taking a look at the equation first. It's given in the form x squared plus 11x plus 30. Now, when we have such a quadratic equation, one of the ways to solve it could be to factorize it. Factoring is like taking an equation back to its simplest form. But how do we factor x squared plus 11x plus 30? We're looking for two numbers that add up to 11 and multiply to give 30. These would be 5 and 6, because 5 plus 6 equals 11, and 5 times 6 equals 30. So let's write out our equation as x squared plus 5x plus 6x plus 30. If we carefully look at this minus written equation, we can factor by grouping. Grouping the first two terms together and the last two terms together, we get x times x plus 5 plus 6 times x plus 5. But wait a minute, did you notice something? We've got x plus 5 repeating in both groups, so we can factor out x plus 5. So our rewritten equation will now look like this: distributor of x plus 5 times x plus 6. And this, my friends, is how we factorize the equation x squared plus 11x plus 30. Thus, the correct answer is D, x plus 5 times x plus 6. In this video, we will be looking at the equation 2x squared plus 5x minus 3 and its possible solutions. The options are A, x plus 1, b, x minus 3, c, 2x minus 1 times x plus 3, x minus 3. Pause the video here and try to solve the equation for yourself. To solve this quadratic equation, we should aim to express it in the form of a product of two binomials. In order to achieve this, we need to find two numbers that have a product which is equal to the product of the coefficients of the x squared term, in our case 2, and the constant term, here minus 3. And the same pair of numbers should also have a sum equal to the coefficient of the x term, which is 5. After multiplying 2 by minus 3, we get minus 6. We are now trying to find two numbers that multiplication gives minus 6 and their addition equals 5. Upon examining the factors of 6, we identify 1 and minus 6 as a pair that satisfies these conditions. Given that 1 multiplied by minus 6 equals minus 6, and 1 added to minus 6 gives us minus 5. However, our goal is to find a pair that their sum is 5. Therefore, if we change both signs, instead of 1 and minus 6, we get minus 1 and 6, and these satisfy our conditions. The next step in our solution is to rewrite the original equation, 2x squared plus 5x minus 3, with the x term plus 5x replaced by minus x plus 6x. So our equation now reads 2x squared minus x plus 6x minus 3. Although it might seem the equation has become more complex, we can now use a technique called factoring by grouping. We separate the equation into two groups, 2x squared minus x and 6x minus 3, and we factor each group separately. From the first group, we can factor out an x and obtaining the expression 2x minus 1. From the second group, we can factor out a 3 and obtaining 2x minus 1 as well. Therefore, we now have two expressions that are the same, 2x minus 1. This means we can factor it out, creating the following equation, 2x minus 1 times x plus 3. Considering the original quadratic equation, we have managed to express it as the product of two binomials, which was our primary goal. Thus, the correct answer is 2x minus 1 times x plus 3. Pause the video and try to solve the problem presented on the screen. 4x squared minus 12x plus 9 and its possible solutions. A. 3x minus 6x plus 9. B. 2x squared minus 3x plus 4. C. 4x squared minus 9x plus 12. D. 2x minus 3, 2. Let's start solving the expression. 4 times x squared minus 12 times x plus 9. The expression is in the form of a trinomial, which can be expressed as a perfect square trinomial when the middle term, that is minus 12x, is twice the product of the square roots of the first term, 4x squared, and the last term, 9. Firstly, find the square root of the first term, 4x squared. The square root of 4 is 2, and the square root of x squared is x. Thus, the square root of 4x squared is 2x. Then take the square root of the last term, 9, which results in 3. Now, check if the middle term, minus 12x, is twice the product of these found values 2x and 3. If you multiply 2x and 3, you get 6x. And if you take twice of that product, you get 12x. The middle term, minus 12x, is indeed equal to minus twice the product of 6x, thus confirming the equation as a perfect square trinomial. Given these variables, the perfect square trinomial can be expressed as the found square roots, 2x and 3, squared. Therefore, putting these terms together, the original trinomial 4x squared minus 12x plus 9 simplifies or factors into the expression 2x minus 3 all squared. Thus, the correct answer is D. Thanks for watching. Comment with how many questions you got correct. Should we make the next video have easier or harder problems? Was the difficulty just right? If you have thoughts for improvements, please share them below. Don't forget to drop a like and sub if you enjoyed the video.